So in today's class, we are going to study analysis of trusses by method of sections. By method of section. Now, in this, what we do is we have already studied method of joints. This is another method wherein we analyze the truss, that is find out the member forces by method of sections. The difference is in method of joints what we do is we happen to find out all the member forces which are there in the truss, whereas this method of sections is basically used to calculate only required member forces. Now, for example, just presume that you can see a simple truss here. It is A, B, C, wherein you have three members here. That is AB, BC, and AC. Now, just think that I want to calculate only AB and BC. Then what I will do is I'll use this method, that is method of sections, in order to calculate these two member forces. Now in method of section, what we do is we draw a line, which will cut the members of which we need the forces. Now as you can see in the second diagram here, okay. Now presume that I am interested in calculating member force AB and BC. AB and BC. Now, if I want to calculate AB and BC, next thing what I will do is I will cut a section. So you can see this section 1, which cuts the two members, that is AB as well as BC. AB as well as BC. Now, one more thing you need to keep in mind is whenever you're cutting a section, you should keep in mind that the section which you are going to cut, it does not cut more than three members. So maximum it has to cut only three members. Okay, not more than three members. So in this truss, I want to calculate member force AB, BC, and AC also, but by method of sections. Now, just concentrate on the truss here. So you can see that ABC is a truss. At point A, you have 10 kilonewton load which is acting downwards. Now, this angle at B is 60, angle at C is 30, which means that angle at A is 90. Very important, it is to be noted here. So this is 90 degrees. This is 90 degrees, right? Okay. Now, what I do is initially I will cut the section 1 such that it cuts two of the members AB as well as BC. Once I cut this two members, next what I will do is I'll assume the direction. So these directions which are given, they are assumed directions. So this section which cuts the two members needs to be analyzed now. So what we do is, first of all, we pass a section 1 that cuts the truss into two parts in the sense. So this section has cut this truss into two parts, that is left of section 1, right of section 1. So these are the two parts. So one part is shown by firm lines, the other part is shown by dotted lines. So those are the two parts. So left side is shown by a dark line, right side is shown by a dotted line. So now consider the equilibrium of left part of the truss. Now what we do is, once the section is cut, next we are supposed to choose either left of it or right of it for analyzing. Now see, I'm using the left part of the section only because there are less number of forces on the left side. That is, I have only two members along with a point force which is 7.5. Now this 7.5 and 2.5, they are nothing but they are reactions. So at B and C, first thing is you are supposed to find out the reactions. So everybody has studied how you calculate the reactions. So this reaction, after calculating the reaction, you have got reaction at B as 7.5 and reaction at C as 2.5. Okay, so they are nothing but reactions. Now what I do is I'll consider to the left of the section, that is 1 1. When I'm considering to the left of the section, I'm going to concentrate only on these three things. These three things, which are those? This member, okay, this member, that is AB, member BC, and this 7.5 kilonewton only. So I should concentrate only on these three things. Now in order to analyze this, I have three equations of equilibrium, that is sigma fx, sigma fy, and moment. I can use all the three equations of equilibrium. Okay, yes. So the next thing what they say is, you are going to assume the direction. Let the direction of forces PAB and PAC be assumed as shown in figure. So PAB, so this is PAB, this is PBC, PBC. Okay. Now, after assuming, next you are going to take moment about moment about point C. Moment about point C. Okay, you are free to take moment about point C or moment about point A. Okay, so we will take moment about point C only. Moment about point C. Now, whenever you take a moment, you should always keep in mind that you are going to use only the forces which are available on the left of the section, because I am dealing and I have told there that I'm going to use the left of section 1 1. So in the left of section, I have only two member forces and one point load. Okay, good. Now next, movement about point C. When I take movement about point C, I have, as I told, three things, two members and one point load. Now amongst these two members and one point force, any force which passes through the movement center, any force which passes through the movement center, yes, it is this BC which passes through the movement center. So amongst three, I am left with only two now, that is AB member force and 7.5 kilonewton, that is the reaction. Now I'll calculate the moment, that is force into perpendicular distance. Now moment at C, force AB, member force AB. Now, I can directly take this AB and multiply it with distance AC, only because this angle is 90 degree, which means it is a perpendicular distance. I repeat, moment about point C is PAB into AC, only because the angle here is 90 degrees, which means that it is the perpendicular distance. So I have written PAB into AC. Now, what type of movement is it causing? What type of movement is it causing? So if you happen to see, it is causing a anti-clockwise movement, for which I have given the negative sign. Negative sign. Okay, now next you are left with one more force, that is 7.5 kilonewton. Now this force is a vertical force, distance to be multiplied is horizontal distance, which is 5 meters, 5 meters. And what type of movement is it causing? It is causing a clockwise movement. It is causing a clockwise movement, and that is why I've used the positive sign, positive sign. Okay, now once I want distance AC now. Distance AC is to be calculated. Now, how do I get this distance AC? How do I get this distance AC? So you just refer this triangle here. You just refer this triangle here. What we did is the same triangle, I have changed the orientation. So this is a right angle triangle only. So the right angle is at A. I have changed the orientation here. Have changed the orientation. So BC is 5 meters. BC is 5 meters. What is angle B? Angle B is 60 degrees. Angle B is 60 degrees. Okay. I want distance AC. AC. So sine 60. Sine 60 is nothing but it is opposite by hypotenuse, which is AC divided by 5. AC divided by 5. Therefore, AC is 5 sine 60, which is 4.33 meters. 33 meters. So this triangle which I have drawn in black, it is nothing but I've changed the orientation of this diagram to get this triangle in order to calculate AC. So AC is 4.33 meters. That is what is being substituted here. It is 4.33. So P minus PAB into 4.33 plus 7.5 into 5. Rearrange the terms here and you will get the value of PAB. Now you got PAB value with positive sign here, that is 8.66, which means that this direction which is assumed is correct, and I have told you that whenever the direction of member force is moving towards the joint, it means that it is a compressive force. It is compressive force, and that is why we have written it is a compressive force. It is a compressive force. So what have you done? You have calculated PAB. Now you have calculated PAB. Next, I want to calculate. Next, I want to calculate another member force, that is BC. I have used this section to cut two members, that is AB as well as BC. Now AB I have found out. Next I'll go to calculate BC. BC. Now again I'm going to consider left part of the section only. Left part of the section only. Now what I'll do is I'll take moment about point A. I'll take moment about point A. Okay. So taking moment of forces to the left part of the truss and about the joint A we have. So what I'll do now is I'm going to take movement with respect to point A. With respect to point A. Now, when I take with respect to point A, again, keep in mind, I have only three things which are to be concentrated. Which are those? AB, BC and 7.5. Why? Because I am considering left portion of the section, means left of this 1 1. So next, if I take movement about point A, we see that this member force AB, obviously it passes through point A. Point A. Therefore, this member force becomes 0. You are left with only two forces. One is BC and the other one is 7.5. 7.5. Okay. If you take movement about point A, the first thing is PBC. PBC. Now this PBC, okay, the perpendicular distance is to be multiplied. So I have drawn a triangle here because I do not know the perpendicular distance between this moment center A and this line of action of force BC. So line of action of force BC is horizontal, as you can see. So it is horizontal here. The distance to be multiplied is vertical. I need to calculate this vertical distance. This vertical distance is being calculated here. Okay. So ABC, wherein you have angle B 60 degrees, this has 30 degrees, and AC is 4.33 meters, which you have already calculated here. You have calculated here. Now, what I do is I will consider this triangle ADC. ADC, and I'm interested in calculating AD, which is the vertical distance. Vertical distance. So this is 30 degrees. This is 30 degrees. Okay. So what I will do is sine 30 is equal to AD divided by hypotenuse. If you consider right angle triangle ADC, so sine 30 is equal to opposite by hypotenuse, that is AD divided by 4.33. Therefore AD is nothing but it is 4.33 sine 30, which happens to be 2.165 meter. Okay, so the vertical distance between moment center A and the line of action of member force BC is 2.165. Okay, so what type of movement is it causing? It is causing a anti-clockwise movement. So you can see that it is causing a anti-clockwise movement. That is why it is taken with the negative sign. So it is minus PBC into AD, which is 2.165. Okay, so it is taken with the negative sign. Next, you have 7.5 kilonewton. 7.5 kilonewton. Now, 7.5 kilonewton. Next, It is a vertical force. So distance to be multiplied, horizontal distance. Horizontal distance. What horizontal distance? If you just refer to this triangle, it is BD. BD. So moment center is A. Moment center is A. This is the force that is vertical. Distance to be multiplied is horizontal. So we do not have the horizontal distance. We are supposed to calculate it. We are supposed to calculate it. Now how do I calculate? For calculation of this, I'll consider triangle ABD. ABD. I'm interested in calculating BD. Okay, so I'll use tan 60. Tan 60. What is tan 60? Tan 60 is nothing but it is opposite by adjacent. I know the opposite distance, that is 2.165. Adjacent is BD. So rearranging the terms here, I can calculate the distance BD, which happens to be 1.25 meter. So horizontal distance is calculated. Okay, so 7.5 into BD, what type of movement does it cause? It causes a clockwise movement. So you can see that it causes a clockwise movement. Thereby I have written 1.5 with the that is positive sign. Positive sign. So rearranging the terms in this equation, I can write this as PBC into 2.165 is equal to 7.5 into 1.25, wherein PBC is 4.33 kilonewton. Again, I have got it with a positive sign, which means that the direction assumed here is correct. Now, I forgot to write the nature of force here. So you can see in this member force, you can see that this direction of force is moving away from B, means that it is a tension force. It is a tensile force. It is tensile force. Okay. Yes. So you have calculated both the member forces, that is AB and BC. So this is how you actually calculate the member forces. Now next, what you can do is I have further enhanced this problem to calculate the member force AC also. AC also. Now, if I have to calculate member force AC also, I have used another section which cuts the triangle in this manner. So you can see that this section is cutting member forces, that is AC as well as BC. BC. Okay. Now have a close look on this triangle. Now in this triangle, only this arrow, that is AC direction, is assumed. So this is assumed direction. Okay. Whereas this direction for BC, it is not assumed, but it is already being calculated here. So you know that the force, the direction, since this is correct, the next arrow will be like this. So it will be in this manner. So it will be like this. Okay. And this is the arrow which is being shown here, which is being shown here. Okay, so you're supposed to keep that thing in mind. You are not assuming this direction has already been calculated here. It has been calculated here. Okay, so now again in this you have cut the section 2 okay. Now again you have two parts. Now you have two parts. One is right of the section which is in solid lines, left of the section which is in dotted lines. Dotted lines. Okay, now here what I do is I will consider to the right of the section. Right of the section, because I have only less number of forces to the right of section. Right of section. Now I'm basically interested in calculating this member force AC. AC. So what I'll do is I'll take moment at point B. I'll take moment at point B. Now again, since I'm considering only right of the section, I have only three forces which are accountable. Which are those? Two member forces, that is AC, BC, and one reaction, that is 2.5. So only these three forces are to be taken into consideration. So since I'm taking moment with respect to point B, amongst these three forces, you see that member force BC passes through the movement center B, passes through the movement center B. Thereby, this member force becomes 0. So this becomes 0. You are left with only two forces. That is, one is this AC and the other one is 2.5. 2.5. That is the reaction. Okay. Now let us calculate the moment. Let us calculate the moment. Sigma moment about B. PAC, which is the perpendicular distance, it is AB. Now again, I'm telling you directly this PAC is multiplied by this distance AB only because this is a right angle triangle. Right angle triangle, because 60, 30, this is 90 degrees, which means that this member is perpendicular to this member, and that is why we are taking it directly. Okay, yes. So AC into AB. PAC into AB. What type of movement is it causing? It is causing a clockwise rotation. So B is the movement center. It is causing a clockwise rotation. Thereby, it is taken with the positive sign. Now next is 2.5. 2.5. Now this 2.5 is a vertical force. Is a vertical force which distance is to be multiplied horizontal distance. And how much is the horizontal distance? It is 5 meters. 5 meters. So 2.5 into 5. What type of movement is it causing? It is causing a anti-clockwise movement. So you can see that it is causing a anti-clockwise movement. So that is the reason I've taken with the negative sign. Now, my next work is to calculate AB. I do not know this distance AB. I do not know this distance AB. Okay. So first thing is I am supposed to calculate distance AB. So I'll form a triangle here. So ABC. So these two distances I have already calculated in the previous steps, that is 4.33, 2.165. Okay, so 4.33, 2.165. I'm interested in this distance now, AB. So how do I calculate AB? It is nothing but by taking sine 60. Sine 60. What is sine 60? It is opposite by hypotenuse. I'm considering triangle ABD. So sine 60 is equal to opposite by hypotenuse, that is 2.165 divided by AB. AB. So thereby, if you rearrange the terms here, AB will be equal to 2.165 divided by sine 60, which happens to be 2.5 meters. So I'll substitute AB as 2.5 meters. Okay. Next, what I'll do, I'll rearrange the terms here, and I will calculate the member force, that is PAC. So this has to be PAC, not PAB. Just small correction. It has to be PAC. PAC. PAC is 5 kilonewton, and you can see that since it is moving towards the joint here, okay, what has happened? It is a compressive force. It is a compressive force. So you have got the answer also with the positive sign. So it is moving towards the joint C. Thereby it is compressive force. So you have calculated all the three member forces.